So we are going to talk about distance in this upcoming lesson. We're talking about 1-4, 1-5. We're going to combine those and really talking about distance in the number line. And one thing to consider, just the basics of distance, is using absolute value, because distance is one of those things that is always going to be a positive value. It may be moving in a different direction, but it's always a positive length or a positive distance. So thinking about that would be talking about absolute value. And the absolute value is referring to the distance from zero. Okay, so on your number line. On your number line is talking about how far are we, the absolute value is how far are we from zero. So the absolute value of 5. So the absolute value is how far is 5 from zero. It's 1, 2, 3, 4. It is 5 units away. So that's why the absolute value of 5 is 5. Well, when you turn around and think about -5, well, how far is -5 from the 0? So the absolute value of -5 is equal to the same. How far is -5 away? It is 1, 2, 3, 4, 5 units away. So therefore, that is why the absolute value of -5 is a positive 5. So just understanding the concept of absolute value. So with that, as we begin talking about distance, distance between 2 points is the length of the segment between the points. Okay, how do we find that length? The formula. If I have this P and Q, the distance formula, is simply taking the absolute value of the absolute value of one of those points minus the other point. It doesn't matter the order, because again, if we come up with a positive value, the absolute value is positive. If we come up with negative value, the absolute value is positive. So therein lies the understanding of that. So if we just plug some numbers in, right? If I say, hey, this is 3, this is 5. Okay, on my number line, that would be, moving in a positive direction. So if I take the absolute value of 5 minus 3 is going to be the absolute value of 2, which we just said is 2. Conversely, if I said the absolute value of 3 minus 5, right, because the order switched, that would be the absolute value of -2. Well, -2 is 2, also away from 0. So either order isn't going to matter in this formula as long as you're making sure that you use the absolute value. So therefore, finding the distance between the numbers, CF, okay? Use that number line and find CF. Well, C is the value of -1, F is the value of 5. So they used F and minus C. So they did some substitutions. 5 minus a -1. Remember that a negative times a negative becomes a positive, so that is actually going to be the absolute value of 5 plus 1. And so the absolute value of 6 is 6. So it would have been the absolute value of 6, and we determined that it is 6. So there you go. That's all we're doing, is using our formula and substituting. I know, that's simple. I don't need the formula. But if I understand the formula on the easy problems, I can use it on the more difficult problems. If I just do a lot of foolish stuff in my head and just jump and make some assumptions, I forget signs, I forget absolute value, all of those wonderful things. So, doing the check here. Use the number line to find the value of AE. A is -5, E is 7. So let's see here, AE is equal to the absolute value of x2 minus x1. AE then is going to be equal to the absolute value, and it doesn't matter which order you use. 7, if we say this is x2, this is x1. 7 minus a -5 is going to be equal to the absolute value of 7 plus 5, or the absolute value of 12, which we said is 12. There you go. This -12 would have been a throwout because we can't have a distance as a negative number. or a length that is a negative number. So there you go. That's how we would do that. And if you had any doubts, if you would use if you would reordered those numbers and had x2, x1, didn't matter, we would have come up with also the answer of 12. All right, so as we go on, determining segment congruence. Remember from last lesson as we learned about congruence. Congruence means things are equal. So if determining if a segment is congruent, if it is equal, then it is therefore congruent. So determine if CB is congruent and DF are congruent. So are the lengths the same? So they took in the values of CB and they said, hey, CB, I have -3 minus a -1, which is going to be plus. So -3 plus 1 is -2. The absolute value of -2 is 2. Doing the same thing with DF, and looking at it, DF looks like 3. But -5 minus 2 is 3. The absolute value of 3 is 3. So yes, they are not congruent. And I know that many of you are going to say, but I could see that they are not congruent. This one is 1, 2. This one is 1, 2, 3. Therefore, they are not congruent. But again, if we can understand how to use them using that formula and the math of a easy problem, it makes larger problems much easier to process one step at a time. Okay? So here, taking a moment, looking at this. Oh, watch out. Subtraction with negatives. Remember that subtracting a negative number is like adding a positive number. Just keep that in mind. So determine whether AC and BD are congruent. All right, let's see here. I'm going to do the math. AC, I got -5 and 1. And I'm just going to say the absolute value of a -5 minus 1 using my formula is equal to the absolute value of -6, which is 6. The other one is the absolute value of BD. I have -1 and 4. All right, so BD is equal to -1 minus 4, which is equal to -5. Therefore, the absolute value of -5 is 5. So it does not look, segments are not or not congruent. Not congruent. Now again, they overlapped a little bit, so you're thinking about it. BD, and then we were also talking about AC. So not as easy to see on the number line just because there's a little bit of overlapping, but going through the motions, it makes it a little bit easier. Understanding how they work. Let's see, so if we keep going here. Distance formula. Now, the distance formula is, we're going to use the distance formula for the rest of this course. So we're learning it now. You've probably been exposed to it in the past, but just so you understand, we will continue to use the distance formula from now until the last day of this class, and you will use it in future math classes. So the distance on the coordinate plane, the endpoints, okay? The endpoints of a segment on a coordinate plane can be used to find the length of that segment by using the distance formula. Herein lies that the last one we did was on a number line. It was a straight line, so all we had to do is do one formula. But now what we're talking about is when we have just 2 points or a segment that is not necessarily a flat line or a straight line, we do a little bit more math to it. So here, the distance formula on the coordinate plane. The distance formula is derived from the Pythagorean theorem. So in Pythagoras said, hey, if you have a triangle, all right, so the Pythagorean theorem, if you had the right triangle, so I have right triangle ABC. I know it's right because I have my right symbol here. That the side length a squared plus b squared is equal to the hypotenuse squared. A squared plus b squared equals c squared. In order to get the hypotenuse by itself, the length of the hypotenuse, or any one of these sides, we're going to do the square root. So the square root of c squared is c. If I do the square root of one side of my equation, I have to do the square root of the other side of the equation. So therefore, c is equal to the square root of a squared plus b squared. Now, looking at the distance formula, that looks very similar. So here, if I take this and I pretend that this is a right triangle, I have this length and this length. I have A, I have B, and I have C. So the distance of my segment is actually the square root of, in this case, A squared plus B squared. But I'm just using those 2 points to find out, calculating those distances. So that is how we derive the distance formula from the Pythagorean theorem. So just keeping that in mind, it is simply taking the points, understanding how they are, and plugging them into our formula and moving forward with that. So being able to break a large formula down into individual steps. So the length of PQ is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. And we will work with this a couple of times for practice. Again, we are going to do the distance formula a lot in this class. So finding the distance between J and K. Well, they gave me the formulas, and they've gone ahead and they've identified them. They said, hey, J is x1, y1. K is going to be x2, y2. And then we just plug the values into our formula, JK. So again, this was x1, y1. This is x2, y2. And we plug those values into our formula and we simplify, okay? So here we have negative 3 minus 4 is negative 7 squared, plus negative 7 minus 3 is negative 10 squared. So we have order of operations. Squaring this, we get 49. Squaring this, we get 100. So the square root of 149 is the length of JK. Approximately, plugging that into the calculator, when you plug in the square root of 149, hopefully you get somewhere along the lines approximately 12 point, we'll call it 2. They didn't tell us what decimal place to round to, but we'll just round to the first decimal place. And that is using our distance formula. So let's see here. So finding the distance between A and B. Here we go. A, x1, y1. B is x2, y2. So using your distance formula, it's right above you on the page. But remember, your distance formula is going to be equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so solving that, I went ahead and using my formula, distance is formula, so I substituted in x2, right, is going to be 5 minus a negative 6 squared plus 9 minus a negative 4 squared. It turned out to be the square root of 11 squared plus 13 squared, which is the square root of 121 plus 169, which is equal to 290. Okay, so 121 plus 169, 290. The square root of 290 is approximately 17.03. That's the decimal. I will say that, okay, so if we say 17.03, if we look here, it does talk about simplifying radicals, practice that we learned in algebra, simple practice, but many students have forgotten it. Do not forget to leave your answer in the simplest radical form when using the distance formula or the Pythagorean theorem. Simplifying a radical. The square root of 290, if I break it down into its factors, I end up with 2 times 5 greatest common. I end up with 2 times 5 times 29, so there's no perfect squares in there for me to simplify. So that's why I ended up with this answer. So we'll talk more about simplifying radicals later. Now here, using the calculator to calculate the distance, same thing applies as before, but they've turned around and given us a little bit more challenging information, not any more difficult, okay? Chelsea and Amy, okay? Chelsea and Amy are sitting in separate cars on the, don't know that one. Chelsea is traveling up Mount Washington and Amy is traveling down. When the two girls notice each other, Chelsea has a horizontal distance of 212 feet from the lower station and is a height of 151.6 feet. Amy has a horizontal distance of 435.3 feet from the lower station and a height of 311.3 feet. What is the distance between the two girls? Incline. Okay, so the incline. There we go. Talking about horizontal distance, right? Vertical distance. And these two people are they've just given you information basically on the coordinate plane. That's what they've done here. And they said, and what they did is said, hey, we have an XY, we have an XY. And they just use the distance formula now to calculate that information. So here, again, they've identified using the distance formula, your XY coordinate, your XY coordinate. Okay, so once we plug in those values into our formula, yes, it requires a calculator because the numbers are a little bit more extensive than what we had before. But here, x2, x1, y2, y1, we simplified, we squared, we combined, added, and then the square root of 75,366.98 is approximately 274.53. Okay, so there's my decimal, approximate decimal of my square root. Chelsea and Amy are approximately 275 feet apart. Okay, they didn't tell me where to round this, so I just said 275. If you said 275.5, you're right. If you said 274, you're wrong, because it's simply about making sure that we round in the correct fashion. So just keep that in mind. Here, snowboarding, here is another word problem. So Manuel wants to go snowboarding with his friend. The closest ski and snowboard resort is approximately 20 miles west and 50 miles north of his house. Manuel picks up his friend who lives 15 miles south and 10 miles east of Manuel's house. How far away are the boys from the resort? Goodness. I don't know. Let's see. Let's just draw a picture here real quick. Okay, so drawing a quick picture. If we think of it as they described it, Manuel lives at the origin, and then we talk about the resort is west, right? We could say that is west. We could say this is north, so we came up with an ordered pair. Then his friend lives south and east, which would be south and east. And then we came up with another ordered pair of locations, and they want to know how far are the two boys from the resort. Well, when he goes and picks up his friend, right, we're basically calculating this distance right there. Not drawn to scale, but we have our values. So understanding that if we had a x2, y2, we have a x1, y1, and then we can use our distance formula to calculate that information. So doing the math, I came up with the distance is approximately 71.589 miles, or we'll just go ahead and say we could either say 71.6 miles or 72 miles, just depending on where you're opting to round your answer to. So just using the distance formula, sort of doing some imaging. I would love to draw a diagram. It makes all my problems so much easier to work out as I'm working. So let's see, moving on, talking about locating points on a number line. Same thing, The big difference here is locating points on a number line with a fractional distance. Okay, you just have to know where to start. And then we're going to calculate the fraction of the distance we're traveling and add it to our starting point. Okay, directional lines, directed line segments. So locating a point, we do have a formula, and it looks like a starting point. And then how far are we traveling? What fraction of that distance, right, are we traveling? So we figure out how far we travel, we multiply it times the fraction, and then we take and add it to a starting point. So we go from a starting point and add how far we're traveling. So just using the formula, we start off somewhere and then we add some portion, the fraction of the distance. That's what we're doing here. So being able to use that formula and just recognizing what we're doing. So here, locating a point at a fractional distance. So find B. I want to find B on AC that is 1/4 of the distance from AC. Okay. Again, the formula. B is going to use this formula. B is somewhere in here. I don't know where it's at. It's somewhere in between there. Visually, we'll come back and do it, but just calculating the distance. X1. X1 is going to start off at -5. That's my starting point. And then I'm going to take, I have X2 minus X1 minus a -5, which turns out to be -5 plus 1/4 times 12, which is -5 plus 3, which is -2. -2. Now you got to remember, we can have a negative number here because we're talking about a location, not a distance. So ideally, this is where B is going to be located, -2. Now, some of you, we could have visualized this. We could have said, if I erase this line so we can see it a little bit better, 1/4 of the distance. 1/4 of the distance between A and C. Some of you may have said, okay, well, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The distance between that is 12. So if I turn around and go halfway, that would be my halfway point, right? 1/2. Well, that means then halfway between that would be 1/4. So this would be my location. So some people's mind works differently, and some people can't see things, but understanding the formula in the beginning for simple problems makes it easy for hard problems later on. So with that, find X. X on BE. So here's BE. That is 3/5 of the distance from BE. So I have a starting point plus a fraction, which happens to be 3/5 of the distance between my 2 points. There you go. So plug your values in. X1, X1, X2. We started at -1. -1 plus 3/5 of 9 minus -1 equals -1 plus 3/5 of 10, which is equal to -1 plus 30/5, which is also 6. So -1 plus 6 is equal to 5. And that's all we're doing with this, determining this location based on a fraction of the distance. So we have a few problems of this. This is all the state of Tennessee is looking for right now. So again, this is just being able to understand we're starting from some place and traveling just a portion of a distance. So there you go. And then that's it. That's all we're going to talk about for this portion. We're combining 1-1 and 1-4 and 1-5 together. Again, now we'll move on into our lessons, and this is to help for those people who need a little bit additional help on today's class assignment.